Systematic qualitative analysis of organic mixtures. Introduction. The qualitative analysis of the organic mixture is quite different from that of the inorganic mixture, since in the latter only the radicals are to be reported, while the former detection of functional groups is not sufficient and one has to report the compound as a whole. Moreover, in the inorganic analysis, we treat the mixture as a whole up to the last stage, but in organic mixture analysis, the actual analysis is done on the individual components for which the mixture is first separated. Hence, primarily we may divide the organic mixture analysis into two steps. Separation of the mixture. Systematic analysis of the individual compounds. Separation of the mixture. The given mixture is separated into two components by a suitable reagent, viz., water, sodium bicarbonate, sodium hydroxide, hydrochloric acid, or organic solvents. After separation, the two compounds, namely the soluble and insoluble, in the pure form are analyzed separately. Systematic analysis of the individual compounds. The two components in their pure forms are now analyzed in the following systematic manner. Preliminary investigation. Detection of elements. Detection of the functional groups. Identification of the compound. Conformation of the compound. 1. Preliminary investigation. Students generally miss this first step, but they must know that it is a very important step and give an idea about the functional group of the compound. Even more than this, some preliminary tests specify a single compound, which however in no case should be considered as final. For the various preliminary tests. 2. Detection of elements. Detection of elements in organic compounds shows us the right path to the next step, viz., the absence of nitrogen in a compound helps us for testing the nitrogen groups, viz., amide, nitro, amino, analyde, etc. 3. Detection of the functional groups. The next step is usually the determination of the class of compounds, i.e., to ascertain whether it is an alcohol, carbohydrate, amine, etc. Students must bear in mind that a compound may also possess more than one type of reactive group. Frequently, the substance exhibits the properties associated with both of its functional groups, e.g. amino-carboxylic acids are dissolved in acids as well as in alkalis. 4. Identification of the compound. After knowing the nature of the functional group, the compound is identified as a particular member of the class. The identification of a chemical individual within a particular class is generally achieved by determining its melting point or boiling point. The melting point of a compound is the range of temperature between which it changes from solid to liquid phase. A pure organic compound has a sharp melting point, i.e., its range of temperature between solid to liquid state does not exceed 0.5 to 1 degree Celsius, while an impure compound melts at an indefinite temperature and its range of conversion from solid to liquid is also of several degrees. The students must remember forever that an impurity in a compound generally lowers the melting point of the compound. 5. Conformation of the compound. Finally, the identified compound must be confirmed by some or all of the following methods. Application of spectral chemical tests. Preparation from the compound, if possible, of a pure solid substance known as derivative and determination of its melting point. Reference is then made to the list of melting points of the particular derivatives in order to ascertain if the melting point obtained with, or near to, that of one of the derivatives in the list. Quantitative analysis in some cases, e.g., determination of the equivalent weight of an acid, or estimation of the percentage of a particular group present. Recording of mixture analysis. In practical notebook, the students should record the observations made during analysis in the following systematic way. Object. To analyze the given organic mixture. No. Test with the mixture. It is advisable to record the following observation with the mixture before separating it into two individual components. Physical state, color, smell, detection of elements, detection of some functional groups, solubility in cold and hot water, separation of the mixture. Give details regarding the separation of the mixture. Systematic analysis of the insoluble compound. Preliminary investigations. Physical state, color, odor, ignition on china porcelain, action of 30% sodium hydroxide solution, the action of hot concentrated sulfuric acid, Reaction with ferric chloride. Detection of elements. Give details for the detection of nitrogen, sulfur, and halogens. Detection of functional groups. Give the procedure for the detection of functional groups, especially for the groups that are found to be present. Detection of melting and boiling point. The compound is found to melt and boil at which degree centigrade. Probable compound. On the basis of the standard data of the melting and boiling points of substances having particular functional groups, the given compound is most probably. Special tests of the compound. Give special tests, if any, for the particular compounds. Derivatives. Give the methods of the preparation of at least 2 important derivatives and also mention their melting points observed by you. Systematic analysis of the soluble compound. Give similar details as for the identification of the insoluble compound. Result. Hence the given mixture No contains the following compounds: